Hello my friends, today we're going to be talking about the derivatives of the natural log. In the last video we talked about this whole idea of taking the integral of 1 over x, this unsolved question from before. Today we're going to approach that exact same idea from the other direction. If we've got our integral of 1 over x dx, or dx over x, and we know that that equals the natural log of the absolute value of x plus c, if we want to try and figure out the derivative from natural log, we can start with this equation. Essentially what we want to do is take the derivative of both sides. On the left, the derivative of the integral cancel each other out and we get 1 over x. On the right, we get the derivative of the whole right side. The derivative can distribute, so we get the derivative of the natural log plus the derivative of a constant. The derivative of a constant ends up being 0, thus we prove that the derivative of the natural log is 1 over x. So now that we've got that idea worked out, we can start to play with it. If we're looking for y prime, we're taking the derivative of both sides. The derivative of 37x is just 37 like before. The derivative of the natural log is 1 over everything in the parentheses. That's my answer. Resist the temptation to put plus c at the end of this. That's an integral thing. We're going old school and we're actually going back to derivatives. Alright, so same plan. However, because we're doing derivatives, we have to remember all of our old tricks. Notice the fact that x squared is being multiplied by this natural log. This is actually a product rule situation. Remember, for your product rule, it's going to be u prime v plus uv prime. So my u is x squared. My u prime, I don't know about you, but I really have to pause here because I write that u equals and I immediately assume that I'm doing a substitution problem. But I'm not. I'm doing a product rule. My v equals the natural log of x plus 3. So my v prime equals 1 over x plus 3. Which means my y prime is going to equal 2x times the natural log of x plus 3 plus x squared times 1 over x plus 3. And that's my answer. I'm going to rewrite this just a wee bit, because I prefer that x squared being up top. That's our solution. Alright, so for this guy, before you start freaking out over the fact that there's an e in the problem, we want to remember all the things we know about natural log. Remember, natural log is the logarithm base e, which means this natural log of e just negate each other and they go away, which means y really just equals 4x. Many students on test day will write this as their final answer and they'll be really proud of themselves. But remember, that's y. I'm looking for y prime. Y prime equals 4. And that's my solution. Alright, so this guy's looking a little weird. My y prime here, follow my rule, it's 1 over stuff in the parentheses. Stuff in parentheses in this problem, though, is a wee bit more complicated. Because it's more complicated, I actually have to remember all of my old skills. One of my old skills was the chain rule. So this is a chain rule problem. The stuff in parentheses is complicated, so I'm going to follow it with times 6x, which is the derivative of the stuff in the parentheses. That's my answer. So I could write it as 6x over 3x squared plus 5. That's our solution. This is just reminding us of that rule. Technically speaking, if you have the derivative with respect to x of ln of u, my answer is going to be 1 over u times u prime. Or kind of function notation, the same kind of idea here. G prime over g. They mean the same thing. So in this problem, I actually have some choices. I could think about what I just saw on the last slide and said 1 over 4x plus 3 to the 4th and then multiply that by that derivative. But that derivative is also going to be a chain rule, so I'd have a chain within a chain, or 2 chains. One move here that I could do is use my log skills. I know an exponent inside the log can move to a coefficient out front. Making that move means that the 4 is no longer an issue, and now it's just one chain. So my y prime is going to be that 4 out front over 4x plus 3, this stuff in parentheses, and then I would do times 4, the second 4 being the derivative of 4x plus 3. Again, I like to pretty that up, so I'm going to say 16 over 4x plus 3. And that is my answer. Alright, very similar problem. Again, I have choices. I could either take this 3 and bring it out front, the same way I just did in example 5, or I might recognize that this ln and e cross out. What you got to be careful of is I can't just cross them out right in the beginning. I've got to bring this 3 in as an exponent first. So let's talk about my first option. The first option was bringing that 3 out front. And so the x squared. Now these guys cancel. Once those guys cancel, this just becomes 3x squared, and my y prime becomes 6x. That's my first path. My second path would be if I want to make this ln and e cancel as my opening move, I've got to figure out how to combine this 3 and this x squared. It's basically a power to a power rule, so I can multiply those two exponents, just using my exponent knowledge. Once those combine, these guys cross out, and then I'm back on the same path. So you can see they end in the same spot. It's just a matter of how you want to approach the beginning problem. But it's mandatory you deal with that 3 first. If you don't deal with that 3 first, it might feel like you're doing it fine, but you're not. You will not get the right answer. Well, this one's kind of scary. I got a square root is kind of the overarching problem, and then I've got stuff on the inside. So remember, my derivative of square root is 1 over 2 square root of stuff. Way back, first half of the course. Times, now I've got to talk about the derivative of stuff. The derivative of stuff, I've first got to deal with the ln, so that's going to be 1 over 5 minus 2x. But that's got a chain rule within it, so then I have to multiply that by -2. Once I'm now done with that ln, I can move on to the rest of the problem. It then says the derivative of 3x. That's 3. So what I've got here is -2 over 5 minus 2x plus 3 all over 2 square root of natural log 5 minus 2x plus 3x. It's pretty ugly once we account for everything, but that's our answer. Again, you've got to think about it as layers. Approach it one step at a time. So my outside most thing is the ln, so I'll begin with that. My derivative of ln of stuff is 1 over stuff times the derivative of that stuff. The derivative of sine x is cosine x. Remember, I am talking derivatives, so watch your plus minuses in front of these. So that's just cosine x over sine x, which you might recall is cotan x. So much like the the tangent had a derivative of negative natural log of the absolute value of cosine, cotan ends up being pretty similar. It's the natural log of sine x. You're welcome to memorize this, or you can just recreate it as necessary. The big walk away is that you recognize how this stuff connects together. Also that you do not mush steps. Many students will write this as 1 over cosine x just because they're trying to do everything, but that's not right. You've got to deal with each piece one at a time, each link in the chain by itself. This here is a classic, absolute classic. I would not be at all surprised if I saw this on the test. The real challenge in this problem is picking the right u. First off, note the fact that we now have an integral out front, which means we are shifting gears and going back to taking our antiderivatives, not derivatives. With this integral out front, if this is not immediately something I recognize, I know it's a substitution problem. That's how I've got u on the brain. For the substitution, I need to be thinking about what the right u is. I've got a couple choices. I could pick x, I could pick ln x, I could pick x ln x. Those are pretty much my only 3 options. U is never just simple x for substitution, so that's out. So my choices are now either ln x or the whole bottom. If I pick the whole bottom, I won't have anything to cross out with, and I kind of lose my leverage, so that's not going to work so well. So instead, I'm going to pick u to be ln x. Going back to du style, so my du is now going to be the derivative of ln x. You see why this is now in this PowerPoint. We didn't know how to do that before, so this would have been a dead end. But now that we know the derivative of ln x is just 1 over x, we can solve this problem. dx will now equal x du. So my integral is going to be x du over xu. Those x's cross out, and now I'm left with du over u. Now, it may not seem obvious, but this du over u is the same thing as 1 over u du, which means I know that integral. That integral is now going to be, that I just stays up front, the natural log of the absolute value of u plus c. Now, here's something funny. U is the natural log of x. So my answer is the natural log, absolute value, the natural log of x. So it's the natural log of the natural log. It's kind of a wacky problem, but it really helps bring to bear all of these skills we're practicing. We've got natural logs in the derivative, natural logs in the integral. It's the whole shebang. Hopefully this made some sense. If not, I'd suggest going back to watch it again.